flat. Of course, it's going to be flat. It's going to be flat enough for you to utilize any construction built within that radius. That's the point of perception where you are. Of course, it's going to be flat. You have to work with some sort of solidification.
When we're surveying and building stuff for the area that's being built on, it's built on flat, but that's only because it's a very big ball, correct? Do you want to expand on that a bit more?
Correct. Yeah. Yep.
So what we actually do on those many acres of land is measure it flat, correct?
Correct.
Do you not like it now? I've reiterated the flat measuring bit that you used in your example.
No, I'm not living up to your reality, mate. You missed out on one.
It was your example of your reality and it being measured flat by your example with a caveat of excuses of how ball-shaped it wasn't.
Be flat. Be flat enough for flat. You be flat enough for flat. You be flat.
Driving in and out and then up and down. Those two things are not analogous. There's no way to connect them. You're doing it just through linguistics in like half-handed attempt, but they're not the same thing. They never will be.
You slipped in a question in the middle of that, which didn't really make much sense to me, but fine. Which was, why would we believe Earth's flat rather than the globe they tell us? Well, because it's measured flat.
I guess, like, the whole bridge construction thing over in America was all bullshit, bull study. But to me, I should look into that case and see if they're actually telling mincy pies in terms of taking the curvature of the Earth into consideration when they built that bridge.
No, curvature of Earth is something that also requires, as a description, Earth be flat to describe it. So curvature, if there was some, would be a deviation from the horizontal plane of reference. So just the very description of curvature in Earth curve maths necessitates Earth have a horizontal plane of reference to describe Earth curvature. So when you say, would you take into account Earth curvature when building things, well, what you would, fantasize about a deviation from the horizontal plane you reference? Because in order to give that description, you'd have to reference a horizontal plane to do it, just like the Earth curve maths does.
So all the elevation and the static involved in finding the actual flatness is compromised. So that what you're saying is that the taking into the consideration of the curvature is actually them taking into consideration of the elevation on both sides of the bridge.
No, I'm saying that to describe curvature in the first instance requires a flat plane to describe it from. And if you're building things like bridges and describing elevations in the vicinity, all of those elevations will be described from sea level. That's a horizontal plane, flat Earth. So you need a flat Earth to describe deviation from the flat plane, deviation from level, that's curvature. So first you've got a flat Earth, then you've got a description of curvature that comes afterwards. You're suggesting that bridge manufacturers would have to account for that which is derived from flat Earth measurements in terms of sea level, and deviations from those levels that you can establish when you build things. Yeah?
Yeah.
Right. And what you're talking about...
The idea of the size... Okay.
What you're talking about them taking into account is probably the resolution loss at the horizon. Would you agree to that? The things disappearing from the bottom up? Is that what curvature is to you or them?
If you see something that is obstructed because it, following a mathematical model and you put two and two together, then yes, that would be the curve interfering there. That would be the argument. Yeah. But that's what one would think. That's you not
understanding the mathematics. That's you not understanding the mathematics you're using. Sea level's a horizontal plane in those mathematics that you just described an obstruction with. What you're actually talking about is the resolution loss between two flat planes, your eye level and surface level. It's not curve.
No, not Earth curve. resolution loss described by their maths using a flat Earth to claim the drop from the plane they call surface level in Earth curve maths. Quick shout out to Jardo. Yeah, you need a flat Earth to assert Earth curve. Did you not know that?
That's right. That's why it wasn't exactly straight when it got to the other end. It was actually on a curvature.
No, did you hear what I just said?
To maintain the straightness, so that would...
You've just reasserted and rinse and repeat the same claim. This curvature you're asserting in your claim requires a flat Earth to be measured to derive the deviation from surface level. That's what Earth curve is. And I'm asking you, given that to claim that they should be accounting for something that is derived from a measurement of a reference plane, in this case sea level, why would you need to account for something that is derived from a measurement of Earth flat? That makes no sense. You're not going to account for something that is derived from how flat you measure the Earth. That makes absolutely no sense. You're using sea level, aren't you, when you're building bridges? You're establishing heights above surface level for all the topology around the bridge and the valley, right? That's how you build things. Well, you need surface level to do that. It needs to be level, not curved. The curve you're appealing to for the third time as you interrupt the third rendition of that which you've ignored. You're now interrupting me. I'll repeat it for a third time because you've hand-waved it twice. Third rendition. You're appealing to them accounting for something that is derived from flat Earth measurements in the first instance. So they're not going to be accounting for that. You can't account for how curved something is when you've just measured it flat to claim how curved it is. That makes no sense.
If they don't account for the curvature, it wouldn't meet on the other side properly.
The curvature...
They literally have to.
It's just ignored me for a fourth time. You don't understand what I've said, do you?
So the engineers that you had talked to...
No, that's not what I said. I said you don't understand what I said, did you? Because you've not responded to it 4 times. So you don't la-la off into a different subject. You didn't understand what I put to you, did you?
That's the point of perception where you are. Of course, it's going to be flat. You have to work with some sort of solidification. If the world was so small and the globe was so tiny, we're on like a baseball, yeah, perhaps that would be problematic. But we're not. We're on a giant, relatively giant Earth, and that brings up the assumption that it's possible for this model to exist in the first place. That's why it's so believable. If it wasn't believable, then the people who are trying to keep it under wraps wouldn't even try because they knew that'd be like a kicking the dead horse, so to speak. They use it to the advantage because it's easily...
Yes, that was thoroughly enjoyable word salad. I've put something to you 4 times. That is to say, the appeal to Earth curve requires a derivation of Earth curve from an Earth that's flat, and you've ignored it.
The argument
5. Now you're chanting 3. Why are you interrupting me? Is this painful? Because it seems that this is now the 7th attempt to put this to you. You've disagreed. I'm expanding on it for you, giving you and your Earth curve maths as the example, where it specifically uses surface level. Furthermore, Al-Biruni's derivation of radius, on screen for my audience a moment ago, flat plane for the height of the mountain, required and necessitated. Earth must be measured as a flat plane to get the heights of mountains for Al-Biruni's radial derivation, and it's a derivation from surface level when you go up the mountain and ascertain eye level. The difference between the two is an inference of Earth curve sphericity below surface level that is flat. So, that's now the 7th time I've put this to you. You, for the inference that bridge manufacturers need to account for Earth curvature, is negated by the fact that inferences of Earth curvature come from measurements of Earth that is flat. I've given you 2 examples. Biruni and surface level in Earth curve maths. Both level, both flat, both the surface of Earth. Flat.
Even a ball has a surface, dude.
Doesn't have any flat surfaces that you would require to do triangles for heights of mountains. Certainly doesn't have those. Certainly doesn't have a capability of deriving differentials between surface level and eye level if you've got a curved surface. Why am I being rumpus when I overcome his rebuttal?
Go on.
I've finished. I've put it to you 8 times. Earth must be flat for you to derive a curve to claim your bridge manufacturers need to account for it. Yeah. That's 9 times. 9 times, my man.
Okay. So what I was saying is with the ball has a surface. Every ball has a surface. If you're a micro-human, like just use your imagination if you can, and you look out to the plane, what would you think it is?
I think it's a begging the
ball or
question
a flat
fallacy.
surface?
Do you want me to answer you, or was it rhetorical? It's a begging the question
just
fallacy. If you
arguing
just
on
tell
that.
me that every ball's got a surface, that's you assuming Earth's a ball. That's called a begging the question fallacy. It's the most
No, it
base
doesn't
form of...
just-
Shut up! Being pummeled doesn't mean you have to chant through me responding to you. What you've just done is beg the question, a logical fallacy. You've chanted through me 9 times. Well, I've put to you that which you cannot respond to, because Earth is required to have a flat surface level to infer the curve you appealed to in the first instance. For your bridge example, now you've had your rebuttal 10 times. It's the first time it's been unimpeded. Would you like to respond to it?
Sure. So what would argue why the engineers have to consider the curvature of this globe when they're constructing a bridge. No. The thing is, you're too stupid to understand my scenario that I put out to you.
Oh, I fully
Imagine
understand
if
it.
you're a tiny, smart little human that you are.
Maybe if you
but
get
you're
really
tiny,
close to your
10,000
mic.
small.
Maybe you're getting really close to your mic.
It's not really that hard to understand. Look at your maths. It's got surface level as a horizontal plane, eye level as a parallel plane, and you're deriving a horizon that exists below surface level. How are you? What are you talking about?
Listening.
Curvature.
That's the problem. He's not listening, John.
Yeah, it's chanted through it.
He
7 or
doesn't
8
have
times.
to.
I just want to read out a quick super chat. Shout out to Unitox Femi, who says, ask him how enormous big giant Earth is, ? Then tell him to use his geometry and to compare it with reality. Thank you for the super chat, Unitox Femi.
Yeah, sure, I'd do that if that was easy to do. Have you guys been in a situation where you've had to build a bridge that long?
Sorry, what relevance does this
here
have?
we are.
Sorry, this has no relevance. We've undone this argument 10 times. Sorry, my friend, unless you've got something else or a rebuttal to what I've put to you, yeah, I'm not interested in talking to you anymore. I've done it 10 times with a lot of interrupting and you getting closer to your mic with your irritation at what's happening.
I thought you told me to get closer to my mic. That's
No, definitely
that
not.
was miscommunication.
That's you not listening and comprehending the words that are coming out of my mouth because you're talking while I'm saying them. You need a flat Earth to derive Earth curve to appeal to it. Now he's chanting through the middle of the undoing of his claim.
Sorry, Tree, Nathan has said to you 10, 11 times that the Earth is measured flat. Did you hear that bit, or did you just ignore it? That's to you, Tree.
Yes, I heard it. It
Cool,
was
so you
measured
heard-
flat.
Good.
Okay.
So that's it. Conversation over. The Earth is measured flat.
And the
less
vicinity
you've
that
got
you're
on-
at, of course it's going to be flat. It's going to be flat enough for you to utilize any construction built within that radius. But when you expand out, then you have to consider the curvature of the Earth because we are tiny compared to the Earth. That is why the perception is when you go outside and you look at the horizon, it is flat. However, science always does this. It tricks us. It creeps up behind us and goes, wakey, wakey, it's not actually flat.
Okay, sorry.
Everything in this universe revolves around a
Just 1 sec.
cylinder.
Jedi, if you don't mind, I'll just pick up the reins again. You said when we're surveying and building stuff for the area that's being built on, it's built on flat, but that's only because it's a very big ball, correct? Do you want to expand on that a bit more?
Correct. Yep. I'll explain that more. So when you're in a construction place and you're looking at maybe there's 50 acres to work with here, the curvature is going to be so minimal that it's not going to affect the work that you need to be done. When you're dealing with construction that is a connection like a tunnel system, underground tunnel system that actually, I guess underground tunnels can actually bypass
just bear with me a
curvature.
second. You're going a bit too quickly. Sorry to butt in. So you
Sorry,
said, you said
so
you're
in the
measuring a few acres.
construction.
Yeah, you're talking
Yeah,
about.
yep. So
we got to a few
so
acres,
it's
and it's just
basically
stop,
yeah.
chill, calm down.
No, I'm okay.
You need an Adderall
sorry,
pill.
just
What's
catch up.
going on? Chill out.
Catch up. So
No,
chill out.
you've
All right.
gone. You've added another thing. Tunnels. You started with
So back to the
acres of
construction
land. Now you won't shut your bleeding mouth. Yeah, you said acres of land. Okay, you said Earth's so big. Yeah, got that bit. So what we actually do on those many acres of land is measure it flat. Correct?
Correct. Because every mile.
Stop.
I think
I'm leading,
is-
mate. I'm leading you,
Oh.
mate. I'm leading you, not the other way around.
Okay, go for it, man.
Yeah, no worries. You just need to shut your bleeding mouth while I talk. Thank you. Yeah. So, In terms of the actual measurements that we're actually dealing with when we do stuff practically, according to you, we measure Earth flat. There is, obviously, a whole barrage of caveats and excuses for why we're not measuring it ball-shaped, but in terms of the facts of the matter, we measure and build on Earth flat. Correct?
Depending on the case. Yeah.
No, not depending, mate. That is how it's done. Why would you be so weaselly as to not concede your own example? These are your examples I'm parroting back to you. Do you not like your own example now? I've highlighted the fact that Earth's being measured and built on flat. As per your example that you gave 3 minutes ago, would you prefer that your example you gave 3 minutes ago did not have Earth being measured flat? Because it is. Do you not like it now? I've reiterated the flat measuring bit that you used in your example.
No, I'm not living up to your reality, mate. You missed out on one.
It was your example of your reality and it being measured flat by your example with a caveat of excuses of how ball-shaped it wasn't. That was your example, and you're telling me I'm denying reality? That seems kind of like projection, given it's not my example, it's yours.
That's ironic.
You chuckle it up, sunshine. That's right, your example was how flat we measure things on Earth, wasn't it, son?
Oh, calm down, boy.
No, I'm not in any way uncalm when I smile broadly because you've given us an example of how Earth is measured flat. Your example, not my fantasy reality. Your example heard by about 100 people in a live audience. So the measurements are flat, the reality is flat, but he's got some excuses for why it wouldn't need to be ball-shaped, it being so big and all. Well done. Yeah, Earth is measured flat, and you will also measure it flat like everybody does.
Guys, the Earth is flat.
Maybe if I get chanted through somebody who's drunk.
The point of perception where you are, of course it's going to be flat. You have to work with some sort of solidification. Of course it's going to be flat. It's going to be flat enough for you to utilize any construction built within that radius.
When we're surveying and building stuff for the area that's being built on, it's built on flat. But that's only because it's a very big ball, correct? Do you want to expand on that a bit more?
Correct. Yeah. Yep.
So what we actually do on those many acres of land is measure it flat, correct?
Correct.
Do you not like it now? I've reiterated the flat measuring bit that you used in your example.
No, I'm not living up to your reality, mate. You missed out on one.
It was your example of your reality and it being measured flat by your example with a caveat of excuses of how ball-shaped it wasn't.